Okay, direct and inverse variation. Mostly dealing with two variables, but there could be more than two variables involved in any particular equation. Um, two variables are directly related if you can get them in the form of y equals a constant of proportionality times x, so y equals kx. The constant cannot be 0, but it can be any other number. So, for example, if k is 2, then you would have y equals 2x. If k is negative 1/3, you would have y equals negative 1/3 x. Now, obviously, the negative 1/3 x, that could be negative x over 3. Probably a little bit easier to see what the constant of proportionality is when it's in this form. Inverse variation. Two variables are inversely related when they're in this form, y equals constant of proportionality over the other variable, y equals k over x. Could be written k times 1 over x. It's kind of handy also to see that the constant is equal to the product of the two variables. So if k equals 2, then y equals 2 over x. If k equals negative 1/3, then y equals negative 1/3 over x. Now, that's not very nice grammatically as far as math is concerned, so probably really should take that extra step and say negative 1 over 3x. Okay, let's do some samples here. Determine whether the variables are directly or inversely related. So, I have an equation here, m over n equals 1/7. Well, that doesn't really match any of the forms we have. Well, maybe it does if we're looking at the constant being 1/7. That would be the y over the x kind of thing. So I'm looking, it looks like it's direct, but let's see if we can get it into that form, the y equals kx form. So for example, if I multiplied both sides of the equation by n over 1, we would get m equals 1/7 n. And so yes, that definitely confirms direct variation. Okay. On the other hand, if we have AB equals -7, the original form of the equation, it doesn't match either of the original equations, but it does match up to a constant equaling product of two variables. So it looks like it should be the inverse relationship here. But let's go ahead and let's get it into the other form, the y equals k over x form. And so if I divide both sides by b, we would get a equals -7 over b. And that definitely confirms that we're in an inverse relationship here between a and b. Now, it's not just the fact that a is inversely related to b. If a is inversely related to b, then that tells us that b is also inversely related to a. Okay, different type of problem here now. Giving you a set of ordered pairs, and directions are to determine if it's a direct or inverse variation. It will be one of those two. We're going to write the equation for it, and we're going to solve for the missing variable. So if you look, the last ordered pair, it's got a missing variable. Okay, I think it's sometimes helpful to go ahead and rewrite this as a table of values this way, where we can see the x's separate from the y's. And a lot of times, I will check for the inverse variation first because of the fact that if they are inversely related, the constant will be simply x times y. So that's a really easy thing to check, and so I typically check for that first. And so I'm looking, I'm going, okay, 6 times negative 3, well, that's negative 18. Negative 10 times 5 is negative 50. So since those two products are not the same, it's not inverse. Not inverse. Okay, so process of elimination, it would seem that this is going to be direct variation, but let's check on that also. If you remember that the constant of proportionality is equal to the y over the x when we're in this form. You don't have to do it this way, but you could. So we could just kind of double check. We could say, okay, so k equals the y over the x, so negative 3 over 6. What does that reduce to? That reduces to negative 1/2. So if we do the y over the x, it should always be the negative 1/2 if that's the case. And so 5 over negative 10, that's negative 1/2, isn't it? And 10.5 over negative 21, that's also negative 1/2. So this is verifying that it is a direct variation. Since it's a direct variation, we can write it in the form of y equals kx. Now, didn't we already happen to figure out what the k is? So y equals negative 1/2 x. There's our equation. And since we have our equation, can't we solve for the missing value as well? So if y is negative 2.5, and it's equal to negative 1/2 times x, so we can solve for x by multiplying both sides by negative 2. And we get 5 equals x. So the missing value for this ordered pair up here, x is 5. Okay, let's try another one of those. Number 4. So we've got 3, 12, negative 72, negative 1/2, negative 4, negative 9, and then 15, y. Okay, so again, I think it's not a bad idea to go ahead and list the ordered pairs. 3, 12, negative 72, negative 1/2, negative 4, negative 9. And if I'm checking the products, 3 times 12 is 36, and negative 72 times negative 1/2 is also 36. That's telling me it's inverse. Just to double check one more time, negative 4 times negative 9, that is also positive 36. Okay, so our equation then xy equals 36, although we typically put it into the y equals form. So y equals 36 over x. Okay, so solving for the missing variable, 15, y. Okay, so, and you could work with either one of these equations. Either one is true here. But y equals 36 over the x. Okay, well, it's a fraction. We always reduce fractions. So let's see, 3 goes in here 5 times, 3 goes into here 12 times, and so y is 12/5 or 2.4. Okay, write the function that models each variation. I've got this listed as part A, part B, part C. On the actual worksheet, it doesn't break it down to part A, part B, part C. It just tells you to do all this in one problem. Okay, J varies inversely with M and directly with P. Okay, well, if J is varying inversely with M, so J equals K over M, and directly with P, so P is up in the numerator there with the K. So J equals KP over M. There's our basic equation. Okay, now they're going to give you some extra information, and we'll be able to solve for the constant proportionality then. So plug in the values that they've got. The only thing you won't know is K, but you'll be able to solve for it. So -12 equals K times, let's see, P is -27 and M is 9. Okay, so I would have K equals -12 times 9, because I'd multiply by 9, and then I'd divide by -27. Okay, now, take a look here. We got negative over negative, so I know K is positive, and I can reduce here some, so 9 over 27, 9 into itself once, and 9 into 27 3 times, and 3 goes into itself once, and into 12 4 times. And I already took care of the plus or minus part of it. So K is +4. So with that, we can write the actual equation here. So J is equal to 4P over M. That's the actual equation. Now, we're going to use that equation to solve for J. So J equals 4 times 7 over -2, which is -14. Okay, let's try another one of those. So number 6, J varies jointly with M and P. Okay, J varies, okay, varying jointly. Jointly, they're both doing the same thing. And really, this is essentially saying it's varying directly with M and P. So J varies directly, jointly, K, M, P. Okay, now we're going to use information to solve for K. So J is 24. K we're trying to solve for. M is 8. And P is 9. So K is 24 over 8 times 9. And let's see, 8 into itself once, 8 into 24 3 times. And that reduces again. So 3 into itself once, 3 into 9 3 times. So we've got K equals 1/3. So now we can write the actual equation. J equals 1/3 times M times P. You could write it J equals MP over 3. But we're going to use this equation to solve for J. So J equals 1/3 times -14 times 2, which is -28/3. So there's J. one more problem here, and then I'm going to get you going on the assignment. Describe how the variables are related. Okay, and jumping straight into the deep end because we've done several of them already now anyway, including the last two problems are kind of similar. So J, let's see, well, it's got an inverse relationship with the fourth root of P, and it's got a direct relationship with M squared. So let's just write that out. J varies, it doesn't really matter whether you say the direct or the inverse first, you could do it either way. J varies directly with the square of M. You could say M squared. And inversely with the fourth root of P.